This is another example of inclined plane with friction, which means a rough surface, which is related to Newton's law of motion. Okay, the question says a ball of mass m1 equals 2 kg and a block of mass m2 equals 10 kg are attached by a lightweight cord that passes over a frictionless pulley of negligible mass, as in the figure. The block lies on a rough inclined plane of angle 30 degrees with kinetic coefficient of friction mu k being equal to 0.3. Find the magnitude of the acceleration of the two objects and the tension in the cord. So we're given m1 to be 2 kg, m2 is 10 kg, the angle is 30 degrees, mu k, which is the kinetic coefficient of friction, is 0.3, and we're supposed to find acceleration, which is unknown, and tension in the cord, which is also unknown. Okay. Of course, we have two systems. 1, 2. For mass number 1, the acceleration is upward, which is the direction of motion is upward. For m2, the direction of motion is downward. And we usually take the direction of motion to be positive. For m1, we're going to take upward to be positive. Which means tension is upward minus m1g, which is downward, is going to be negative, equals m1a, and we're going to call this one to be equation number 1. And for m2, which is where the motion is downward, we're going to take downward to be positive. And what is downward is m2g sine theta, which is the driving force. We're going to write m2g sine theta minus the tension in the cord, which is upward, minus friction, which is upward, equals m2a. Friction always opposes the motion. If the motion is upward, it's going to be downward. If the motion is downward, it's going to be upward. And now we're going to add the two equations, 1 and 2. We call this one to be 2. So the tension, the positive tension and the negative tension will go away or fade away. Okay? And we're going to get the driving force, which is m2g sine theta minus m1g minus the friction force equals the total mass m1 plus m2a. So friction in general is mu k, in this case, this is Fk, N. Okay, what is N in this case? Is the normal force, which is in line with m2g cosine theta. They're in opposite direction. Therefore, the friction force is mu k m2g cosine theta. This is our friction. So we're going to replace Fk by mu k m2g cosine theta. we're gonna have m2g sine theta minus m1g minus mu k m2g cosine theta being equal to m1 plus m2a. So a in this case is going to equal m2g sine theta minus m1g minus mu k m2g cosine theta divided by m1 plus m2. Okay. And now we're going to plug in the numbers. M2 is 10. G is 9.8, but we just write 10 for convenience. Sine 30, which is 0.5, minus M1G, 2 times 10 for G, minus mu K, which is 0.3, M2 is 10, G is 10, cosine 30. Divided by 2 plus 10. And the answer to this one is .335 meters per second square. This is the acceleration. And now we can find the tension in the rope and the cord by using equation number 1, this one. So we're going to say T minus M1G equals M1A. Therefore, T equals M1A plus M1G. And we can take M1 as common factor, A plus G. Plus 10. And the answer to this one is 20 and 0.7, almost 20.7, of course. Newton is a little bit smaller than 0.7, but we just assume it is 0.7.